You can see in the slide that is the calendar of Einstein's speech in Prussian Science Academy. And that happened in all Thursdays. They are called the Golden Thursdays, 4 Thursdays. And there is a very nice story behind that. When he actually agreed to do that lecture, somewhat in March 2015, he was almost sure that his theory about gravity, which was formulated in 1911, is completely true. But after agreeing for this lecture, he went to Göttingen to meet the great Hilbert, and Hilbert attended Einstein's lecture, taking notes, sitting in the front. And after completing the lecture, Hilbert wrote a letter to Einstein. Your lecture was fine, the idea was fine, but I think that there are certain serious errors in that, so I am going to work on that. That was Hilbert's threat. Hilbert being at that time, he was the most eminent mathematician, and he started working on general relativity, and he derived the Einstein's equations 5 days before Einstein. Actually, some people call it as Hilbert-Einstein equation. And then Hilbert said that the idea came from Einstein, therefore the full credit is to be given to him. That is his magnanimity. And in that you can see that on the first Thursday, that is 4th November 1915, on general theory of relativity, that was his first lecture, and that was completely wrong. And if you look at that equation, you can see that, I don't have time to explain that, you can see that any undergraduate student who has some rudimentary knowledge about differential geometry will see immediately that equation is wrong. And next week, he completely corrected that. That is called the addendum on the general theory of relativity. That is, second Thursday, he published the correct form of general relativity equation. I am not going to explain that. I am going to say the story only from 1907 to 1911, as far as how much we can go, I don't know. But up to the point of 1911, you don't require much differential geometry. Like most of us, we are not experts in differential geometry. Therefore, I will be mainly concentrating on the physics of the situation. But the entire physical idea developed by Einstein up to 1911, that is completely true. It culminated in the beautiful Einstein's equations in 1915, that is true. So we will start there. That is Newton sitting under the apple tree, and you all know that equation, F is equal to gmm by r square, and F is equal to ma. Those two equations actually completely describes the entire classical mechanics up to 1900. In 1905, Einstein came and everything changed, that you all know. But I am not going to read what is written there to save time, that you can take your own time to read that. I am not going to read that. But there are certain very serious problems related to these equations. I am not describing all the problems. I am selecting 2 of them. The first one, if you look at that, you can see that if you combine F is equal to ma and F is equal to gmm divided by r square, both taken as force. And then if you write ma on the left hand side and gmm by r square on the right hand side and cancel out m, you can see that the acceleration is a constant, that all of us know. But the mass appearing in F is equal to ma is the result of inertia. It actually tells a particle what should be, if you apply a force, what should be the acceleration. That is a measure of inertia. And the m on the right hand side is the ability of that mass to produce gravitational field. There is no connection between them. There is no connection between inertia and gravity as far as Newton is concerned. They are two separate equations. Then, how come the cancellation of m on both sides? That is technically called the equality of gravitational mass and inertial mass. There is no logical or scientific reason behind that. Only the experimental thing. We know the famous experiment of Galileo. He is standing on the leaning tower of Pisa and dropping two separate masses and claimed that they both of them came down at the same time. And this is an experiment done in Apollo 15 experiment. David Scott is actually astronaut of Apollo 15. He is dropping a feather and a hammer, and he actually that movie is in the internet you can search for that Apollo 15, you will get that movie. That is not clear, that is why I have used a painting. That is a painting. He dropped those two and found that it is, and the acceleration being same, that has been experimentally verified up to an order of 10 raised to 13, 1 over 10 raised to 13 accuracy. The earth and the moon falls towards the sun at the same rate. By lunar ranging experiments, they have actually verified that. This is the problem. Next problem. Gravity is you cannot abolish gravity. You cannot switch off gravity. Gravity is everywhere. If you consider gravity as a force, it is clear that you cannot define an inertial system. In Newton's law of motion and subsequently in special theory of relativity, we require the concept of an inertial frame of reference. Newton's first law tells you what an inertial frame is. That is the first law. That is the necessity of first law, because second law is valid only in a frame of reference where the first law is valid. So first law actually defines inertial frame, and it tells about a frame containing particles on which no force is acting. But you cannot imagine such a frame of reference because you cannot switch off gravity. Gravity is everywhere. Gravity is universal. All particles universally respond to gravity. You cannot switch off that. Therefore, you cannot define an inertial frame of reference. And that problem actually Einstein was most unsatisfactory to me, that although the relation between inertia and energy is so beautifully derived, he derived the relation E is equal to mc square in 1905, but by 1907 he was completely doubtful about that, and he said that there is no relation between inertia and weight. That was his problem. In another way, we can say that that is the equivalence between inertial mass and gravitational mass. And he actually thought that there should be some more fundamental rule of nature which tells you why this inertial mass and gravitational mass are equal. Not by experiment. Einstein was a thorough physicist, a perfect theoretical physicist. He believed in experiments, he made wonderful predictions in experiment. But he never decided or put forward the merit of a theory based on its experimental validation. This equality is experimentally validated, that is true, but he thought that there should be a more fundamental reason, and that is written here. The happiest thought in my life. That was what? You can read that. I was sitting in a chair in the patent office in Bern. And the thought came to me that a person falling do not feel his weight. And that is the happiest thought. And we can see that the entire thing, entire general relativity, the entire theoretical foundation of cosmology, black hole, gravitational waves, everything is based on that single thought. That is, a person falling freely do not feel his weight. I don't know, you can see that picture, that person is falling freely. If you imagine yourself to be falling freely, I don't know how you will feel. But actually, falling freely do not have any effect. You can, if you take a 1 ton mass on your head and you break your neck, you should not blame gravity. Gravity is not responsible for that. It is not gravity which breaks your neck. Your neck is broken. If you have to blame somebody, we have to blame actually Pauli. It is due to the Pauli exclusion principle, that is 2 electrons cannot share. That is why it is being broken. Gravity is innocent there. You are standing on the ground, you feel your weight, not because of gravity, but because of this normal force. Normal force is electromagnetic, it is not gravity. Therefore, if you completely remove all other sources of forces, and outside the nucleus we have only electromagnetic force to be removed. You remove electromagnetic force and you have only gravity. And when you have only gravity, you are free fall. You don't feel the weight when you are falling freely. Actually, we will feel the weight due to the presence of the air, due to the pressure, and due to the anticipation of the fact that we are falling and we will be losing our life. That anticipation also causes some pain, but that is not gravity. That is entirely different thing. So, this is the happiest thought. So, I have drawn those pictures there. And Einstein, and that is why Einstein is Einstein. From this simple thought, he brought forward 2 very nice observations. The first one, if you look at that, the chamber 2 and 3, one is at rest on the ground, the other is accelerating upwards with an acceleration g, and the second chamber and the first chamber are exactly identical. That is what the principle of equivalence says. A person sitting on the ground and a person in the outer space accelerating with the g upwards are exactly equivalent. One cannot distinguish between those two. Of course, they can be distinguished, that is another story. They can be distinguished when the gravitational field is non-uniform, because there are certain forces called tidal forces which will skew you like this and elongate you like this. That is responsible for that high tide and low tide. Those tidal forces, apart from that, if you consider gravity to be uniform, then this is an exact principle. That is one thing. And the second thing is that if you consider a light beam, if you take those two, a chamber which is accelerated, you take 2 different masses, you put it like this, they will stay there, but the floor will accelerate and will meet these balls. And that is what is happening. There is no need of equality between gravitational mass and inertial mass. There is no need of that. Mass doesn't have a role. This floor doesn't care where this is an elephant or an amoeba or an atom or whatever it is. This floor will come and hit at the same time. It is not these objects are falling down. Instead of that, this floor is accelerating up. And it is hitting at the same point. And that clears the year-long or several centuries old doubt about equality between inertial mass and gravitational mass. Another consequence has been this. The light beam will be bending. You know that it is moving up and some half GT square type situation, and there will be a curve, and the floor doesn't matter whether it is photon or a particle or an atom or a cell, whatever it is. It will be accelerating towards that. Therefore, light will appear to be bending. These are the 2 very important conclusions Einstein made from this principle of equivalence. And when you look at that, you can see this is due to the that is a reformulation of Newton's first law. There is no straight line motion like that. He reformulated that the standard motion is a free fall, and when the particle is falling, the free fall trajectory is called a geodesic. It is moving. A free fall trajectory is not a straight line. It is an inertial, a free fall, freely falling coordinate system is an inertial frame, because it is no force is acting on that, no gravity, no all other forces are removed, therefore it is an inertial system. And when it is moving an inertial system, the particle actually moves through the shortest path, which technically called a geodesic. We don't have, I always tell you to sit down and work. It is not as people usually think, differential geometry, laser, the tensor analysis, general relativity, etc. is not hard to understand. You will have to do some initial work to be familiarized with the notations and indexes, etc. After you are familiar with it, it becomes second nature to you. It is extremely simple. Therefore, you can do that, and that is a problem. People actually are happy to find Einstein to be wrong, because nobody likes him because of several reasons. Even his wife did like him, because nobody will like a husband who is at the year of 27 or 28, instead of building up a career, going after the structure of something which nobody can see or experience, space-time structure. Nobody will like him, and that is therefore people actually thought of something to prove that Einstein is wrong. That is that when light bends, that is the problem. When the light is bending, you know that the top path and the lower path will be moving with different speeds. It is the faster and slower that I have written there. Not I have written there, this is somebody else's picture, not mine. But Einstein found a very beautiful solution for that. It is not the velocity of light changing, but the time becomes slower. The time at the bottom line of that light beam, which is at a nearer to the gravitational source, is having a slower time compared to the upper part. That is why it is traveling the smaller distance with the same velocity. And that explanation, that is, I have written there, the rate of ticking of clock will depend on the gravitational potential. I will give you a very small elementary high school level derivation. That is that. I only anticipate that you know the formula for the special relativistic formula for time, that is root of 1 minus v square by c square. And I have three clocks there, A, B and C. The Alice's clock is at the top, Bob's clock middle, and the Charlie's clock there, and David is coming down. And he is accelerating, coming down in a free fall. And we know that a freely falling David is in an inertial system. And when he reaches B, he look at the clock of B and find what is the time. The velocity we all know, that is a high school level physics. You start from infinity, there your kinetic energy is 0, potential energy is 0. That is, this is a slowly moving system, therefore no relativistic effect need to be introduced. You just think that half mv square plus m phi is equal to 0, and you can calculate your v square, that is 2 phi, and your time of the Bob's clock will be dt root of 1 plus 2 phi by c square, and if you put phi is equal to minus gm divided by r, you get a very interesting formula. dtb is equal to dt root of, or dtb square is equal to dt square into 1 minus 2 gm by c square r. This is a very simple derivation, that is not at all true to the actual workings of that. But when you look at that equation, you can see that this is a very fundamental solution of Einstein's equation. This is the first solution of Einstein's equation. First solution of Einstein's equation was due to Carl Schwarzschild, and he solved the equation, and the solution of Einstein's equation is the determination of an entity called a metric, and the time component of the metric G00 of Schwarzschild metric is that 1 minus 2 gm by c square r, and that 2 gm divided by c square is called the radius, Schwarzschild radius, that is the radius of the event horizon of a black hole. If your radius r becomes equal to 2 gm divided by c square, you can see that your time becomes 0. That is why you say that on the surface of a black hole, your time becomes 0. You are frozen in time. If you are ready to go to a black hole with your watch, when you reach the surface, your watch will stop working because of that reason. And if you look at the other figure, you can see that your head is getting older than your feet. Your head is farther from the surface of the earth. But don't be panic, because your head will be older than your feet by a time of 1 second if you live for 100 million years. Therefore, it is not a problem. If you live for 100 million years, your head will be older than your feet by 1 second. It is such a small effect, and it is such a small effect, but it has several consequences. The first consequence is that here I have exaggerated it very much. In the ground you have 2 waves, and your clock shows 1 second, and in the top that is faster, that clocks 2 seconds, and in the down, if you have 2 waves per second, that is the measure of frequency you know. At the top you have 1 wave per second, and therefore the frequency is, you look at that, the frequency decreases, and therefore the wavelength increases, it shifts towards the red region, and that is precisely called the gravitational redshift. But that is extremely small, like the millionaire. If your friend in the downstairs will be younger than you compared to you by this much time, because it's extremely small. But it has a very important practical application which I have written there, that is GPS. You are using your GPS always. When you are using your Google map, you are actually relying to those GPS satellites, that is at a distance of about 20,200 kilometers and traveling at a speed of about 14,000 kilometers per hour. And if you look at that, you can see that there are 2 effects. One effect is due to the speed of the satellite, that is the special relativistic effect, which makes the clock on the satellite go 7 microseconds per day faster. Due to the effect of gravity, that formula I have written, T0 root of 1 minus 2 gm by rc square, because of that there is 45 microseconds per day slower. Therefore, your clock, your watch, or your receiver in your GPS receiver in your mobile phone is 38 microseconds slower per day than the atomic clock on the GPS satellite. We may think that 38 microseconds is a small value, but it is not true. It will create an error in a distance of 11 kilometers per day. These clocks are continuously being corrected. Sajid may be knowing more about the tracking algorithm of that, but it is being corrected by sending signals from the control station. As far as I know, AI technology has not entered to that area. It is not automatic. If a person, for example, a person in the control station is on leave, he didn't send error code to correct that, then what is happening is what I have shown there. After this lecture, somebody of you got interested in theoretical physics and is planning to go to IIC Bangalore on your car, traveling about 10 hours, and there is all possibility that you will end up here. Your GPS will say that on your right you can see, if I am going in that direction, the C.V. Raman Road, right, you can see the Indian Institute of Science, your announcement is there, but you will see, you could see you are drowning in the Ulsur Lake. That distance is about 6 or 7 kilometers. That much error can happen. This is being done on a periodic basis. Otherwise, if you didn't correct the atomic clock for this particular correction, gravitational correction, according to general theory finds your application in your daily life. Whenever you use your Google map to search for a restaurant, you should be thankful to Einstein. Do I have time? How much time? 5 minutes?
2 minutes more.
10 minutes. Okay,
No,
fine.
2 minutes.
2 minutes. Oh, that is too little. But I will conclude with this. There I have drawn, actually for a particle, in the perspective of relativity, a particle has 4 velocity, and one velocity is the velocity in time. That is, the formula is written there, dx mu by d tau is the proper time that you will learn in special relativity. I am not going to details of that. And if you draw the diagram, I am speaking about only of time, only of the curvature in time or the warping of time. I am not taking into consideration the warping of space. Warping of space is very negligible role as far as solar system is concerned. That is very important when you go near a neutron star or black hole. But as far as solar system is concerned, entire gravity is due to the time wrapping, not due to the space wrapping. Space is almost flat, but time is wrapped. I have given you the formula for that just earlier. And when the time is wrapped, that is, I am showing here, that is a diagram which is called the space-time diagram. On the vertical axis you have the time, and the horizontal axis you have the space. Normally, when you have a particle at rest, you have the whirl lines of that. It is called whirl line. Whirl lines are parallel lines because you are at rest. You don't move. Therefore, you are actually moving through time. You are moving through time with a particular velocity. That is your u0. That is technically that is u0, the first component, the time component of the velocity for vector. And you are moving in that direction. But due to this time wrapping, your clock near the earth is lower and there is a gradient of time. And that gradient of time, which is called the time wrapping, actually creates gravity. How it creates gravity, you will have to find out the metric g mu nu. Monsi has told me that കുറേ നാളായി സതീഷ് ജി മ്യൂ പറഞ്ഞിട്ടെന്ന് മോൻസി ഇപ്പോൾ പറഞ്ഞതേ ഉള്ളൂ. അപ്പം ജി മ്യൂ പറയേണ്ടി വന്നു ഏതായാലും. That particular thing, that is G00, you just use that to calculate something which is called the connection coefficients. From that you can write the geodesic equation, and that geodesic equation directly gives you the dynamics. That is a very interesting feature of Einstein's equation. That is the beauty of Einstein's equation. For all other equations in physics, for example, for gravity, you need Newton's laws of motion as well as F is equal to ma. F is equal to ma permits you to take the dynamics. If you go to Maxwell's equations tell you about the electric field and magnetic field. It do not tell you about what is the force. Force is to be calculated from F is equal to Q multiplied by E plus V cross B, that is Lorentz force. You require another force, another equation. Here that is not needed. Einstein's equation is complete. If you solve Einstein's equation, you will get G mu nu, and that G mu nu will be used for calculating the geodesic equation. Once the geodesic is known, the particle path is completely known, whether it is light or elephant or planet or star, whatever it is. It is universal, much more universal than Newton. I will stop with one more comment. I am not going to show you the geodesic. It is there. Geodesic equation. Sorry, that is, I am not going to touch that. I am stopping with this, so I am not going to that slide. You just look at that. That is instead of that time current which I have marked there, here you have a water current, and you are taking two boats, and the boat far from the shore or the edge is moving with a higher velocity, and that nearer to that moving with a smaller velocity, just like this, just like the clocks nearer to the earth and farther. And after some time, if you connect them, you can see that there will be a turning away, turning of the faster boat towards the bank, and that turning is actually the gravity. Therefore, if you take a body, that each atoms of that body, each particles of the body can be considered to be a clock. Everything can be considered to be a clock. Everything which has periodicity can be considered to be a clock. All atoms can be considered to be a clock. And that clock time is having that gradient. And that gradient produces a motion towards the source of gravitational field. Actually, it is not true. Actually, you have to solve the geodesic equation. Solving geodesic equation is not a big deal. That you only thing required is you need some patience. That is all. Nowadays, you have very nice computing softwares like R or Octave or MATLAB or Mathematica, whatever it is. You can simply do that. At our time, it was not like that. We will have to know computers, browser, etc. He has to sit down to. If you want to inverse a matrix, you have to sit down and do everything by hand. Nowadays, it is not needed. Therefore, it needs only a little patience. Therefore, I am stopping here. I am inviting the comments and any doubts. No doubts. Any comments or suggestions? Okay, Suresh.
Yeah. So I have some comment on this wrapping of time against gravity.
Yeah.
Is it the other way around?
Other way around means?
Gravity can wrap the times, not the times can create.
But I think it is the way like this, because I think that you can argue that gravity produces warping like that, but I think you have a source of gravity. You have a source of gravity, and near you have slower time, and that source produces warping of space, warping of time. I have not dealt with space. Therefore, this source of gravity produces warped space. Warped space produces gravity, not the other way around. I think that is my way of interpreting that. When you have a massive body, source of gravity, that massive body warps the time near that. Warp time produces gravity, not the other way around. Gravity produces warp time. It is not like that. The source produces warp time, and warp time produces gravity.
That's some argument. Logically, you need a source for gravity.
Yeah.
Gravity can only affect the space and time.
Yeah.
Not the other way.
Not the other way. Gravity affects space. No, not space.
That the wrap of times can create gravity.
Yeah, that is right. That is what I was trying to show by that boat analogy. That is, this boat moving with higher speed when connected moves like this towards the slower time. That is gravity. Therefore, the source creates warp time creates gravity.
There is only a source for gravity.
Yeah, correct.